Hello everyone, welcome back to maths class chapter number 25 probability. The next exercise 25b. Question number 1. 9 cards identical in all respects are numbered 2 to 10. A card is selected from them at random. Find the probability that the card selected will be. Now the question is, there are numbers 2 to 10 which are placed on the card. So if you count from 2 to 10, then all possible outcomes will be equal to 9. Now let us see how we can choose the number and find the probability that the first sub question is to get an even number. Kindly note down all the possible outcomes, children. It is easy to count. So which are the even numbers? 2, 4, 6, 8 and 10 are the favorable outcomes. If you count, then there are 5 favorable outcomes. Hence the probability will be equal to 5 by 9. I repeat, we have a numbers from 2 to 10. The cards which are having the numbers 2 to 10, kindly count 2 to 10, then the total outcome will be equal to 9. From this card, that is 2 to 10 mark, we need to pick a number which is an even number. Among 2 to 10, which are the even numbers? We have to list out. So kindly note down the favorable outcomes. Don't miss even a single outcome here. So 2, 4, 6, 8, 10. Again there are 5 outcomes. Hence the probability of getting an even number is 5 by 9. Sub question 2, it is a multiple of 3. Which are multiples of 3 among 2 to 9? It is 3, 6 and 9. Hence the favorable outcome is equal to 3. The probability will be equal to 3 by 9. Its simplified form is 1 by 3. And the sub question 3, it is an even number and a multiple of 3. Kindly note down this point, children. An even number and a multiple of 3. If there is a word and between any two conditions, it says that the favorable outcome should satisfy both the conditions. So in this example, we need to find out an even number which is also a multiple of 3. Let us cross check once. First, it is 2. It is an even number but not a multiple of 3. Next, number 3. It is a multiple of 3 and not an even number. Next, 4. It is an even number and not a multiple of 3. Next, 5. It is neither an even number nor a multiple of 3. Next, it is 6. 6 is an even number and also a multiple of 3. So let us write down 6. Next comes 7, 8, 9 and 10. Anyhow 7 and 9, 7 is not an even number and not a multiple of 3. 8 is an even number but not a multiple of 3. 9 is a multiple of 3 but not an even number. 10 is an even number and not a multiple of 3. So hence we have only one number, that is 6, which satisfies both the condition, that is an even number as well as a multiple of 3. So outcome number is 6 but number of favorable outcome is only 1. So when you are listing out the numbers, don't get confused with the outcome and its number. We need to take its count, not the number. So write down the elements, what you are going to get outcome, then count the elements and take it for probability. So number of favorable outcome is equal to 1. Probability of getting a number which is even number and a multiple of 3 is 1 by 9. I repeat, children, if you have a word called and between two conditions, then we need to find out an outcome which satisfies both the given conditions. Sub question 4, it is an even number or a multiple of 3. Now we have a choice. That means to say, if you have or, there is no condition. If one condition satisfies also, we can find out. That means to say, among 2 to 10, I can take all even numbers, I can take all multiples of 3 irrespective of the condition that both should satisfy. So 2 is an even number, 3 is a multiple of 3, 4 is an even number, 6 is even number as well as a multiple of 3, 8 is an even number, 9 is a multiple of 3 and 10 is an even number. So if you count the favorable outcomes, it is equal to 7. Hence the probability will be equal to 7 by 9. Question number 2. 100 identical cards are numbered from 1 to 100. The cards are well shuffled and then a card is drawn. Find the probability that the number on the card drawn is. So there are cards numbered from 1 to 100. So total possible outcomes will be equal to 100 and the formula to find out the probability remains the same. Let us concentrate on the sub question. The first sub question is 5. List out all the multiples of 5. It is 5 to 100. Here we can know that in numbers from 1 to 10 we can have two multiples of 5 like 5 and 10, 15 and 20, 25 and 30, 35 and 40, 45 and 50 and so on. Hence if you count the number of favorable outcomes it is equal to 20. Then the probability of getting a multiple of 5 is 20 by 100 that is equal to 1 by 5. The next concept is a multiple of 6. All 6 ones are tables up to 100. So it is 6, 12, 18, 24, 30, 36, 42, 48 and so on and the last value is 96. Hence a multiple of 6, there are how many favorable outcomes children? If you count, you can note down there are 16 favorable outcomes. Hence the probability will be equal to 16 by 100, hence it is 4 by 25. And the sub question 3, it is between 40 and 60. Here also note down this children, when it is word between 40 and 60, then we need to exclude the first and last number. That means in this example, I need to take a number counting from 41 and I should stop by 59. If it is from and to, that is the other case. When it is between 40 and 60, consider the number after the given number, that is after 40 it is 41 and stop by 59, don't include the last number. So when it comes to between, exclude both the given values that is 40 and 60, consider the values in between the given range here. So now here it is 41, 42, 43, 44 and so on up to 59. If you count, then there are 19 numbers, hence the probability is equal to 19 by 100. Next is a number greater than 85. Greater than 85 is, it starts from 86 and the last number is 100, that is the range, that is the cards we have up to 100. Hence there are 15 cards, the probability is 15 by 100, that is equal to 3 by 20. Next it is less than 48. Less than 48 means in this case also we cannot consider 48, we have to stop by 47. A value less than 45, it means 48 should not be considered. If you count from 1 to 47, so the outcomes is equal to 47. The probability is 47 by 100. Question number 3. From 25 identical cards numbered 1, 2, 3, 4, 5 and so on up to 25, one card is drawn at random. Find the probability that the number on the card drawn is a multiple of 3, 5, 3 and 5, 3 or 5. So as there are 25 cards, total possible outcome is equal to 25 and the formula remains the same. Let us concentrate on the sub question. The first sub question says it is a multiple of 3. Which are the multiples of 3 between the given numbers 1 to 25? They are 3, 6, 9, 12, 15, 18, 21 and 24. Once if you count this, you will get the number 8. Hence the probability is 8 by 25. The sub question is multiple of 5. List out the multiples of 5 children, 5, 10, 15, 20 and 25. So there are 5 favorable outcomes. Hence the probability is equal to 5 by 25, which is equal to 1 by 5. And the third sub question is sub question 3. It is a number getting a multiple of 3 and 5. Let us cross check once children which are the numbers which we can find. both the conditions to satisfy, that is a multiple of 3 as well as a multiple of 5. So 3 is a multiple of 3 and not a multiple of 5. Then 6 is a multiple of 3 and not a multiple of 5. And 5 is a multiple of 5 but not the multiple of 3. Like this, by if you go on checking both the conditions, a number should satisfy. The only one number we can find is 15. Hence the favorable outcome is equal to 1, that is 1 by, probability is 1 by 25. Next it is a number getting a multiple of 3 or 5. In this case we can have many outcomes, that is all the multiples of 3 and all the multiples of 5, and kindly don't repeat the numbers. For example, 15 is a multiple of 3 as well as the multiple of 5. It is not necessary to repeat the numbers because only 115 number card we can have in that set. So don't repeat the numbers, only try to find out the outcome which is going to satisfy the given conditions. The numbers which is getting a multiple of 3 or 5, then the favorable outcomes are 3, 5, 6, 9, 10, 12, 15, 18, 20, 21, 24 and 25. The total number is equal to 12. Hence the probability is equal to 12 by 25. Question number 4 is related to the dice, children. A dice is thrown once. Find the probability of getting a numbers less than 3, greater than or equal to 4, less than 8, greater than 6. I hope by this time you will be able to solve the problems of dice. Total possible outcomes is equal to 6. Note down and solve all 4 sub questions as a continued part in the same classwork. Let me move on to the next question, that is question number 5. A book contains 85 pages. A page is chosen at random. What is the probability that the sum of the digits on the page is 8? Understand the question, children? There is a book which contains 85 pages. That means to say a book is numbered from 1 to 85. 1, 2, 3, 4, 5 and so on up to 84 and 85. Now as it is 1 to 85, total possible outcome is 85 and the formula remains the same. Now the question is, there is a page is chosen at random. So what page number is chosen at random? That page number, the sum of the digits on the page number should be equal to 8. Let us just think practically. If I open a book randomly, I got a page number as 25. Add 2 plus 5, what is the answer? 9. Whether the condition is satisfied? No. In the same way, let me check a number. If I open a page, I got a number as 62. 62. 6 plus 2 is 8 and the condition will be satisfied. Like this, we need to cross check from page number 1 to page number 85. Here we can use our common sense. From page number 1 to 10, there is no possibility because we cannot add the digits. It is one digit, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9 it is ruled out. It is not necessary to check. The next number comes is 9, 10, 11, 12, 13, 14, 15, 16, 17. 1 plus 7 is 8. So like this we need to cross check and think and list out all the favorable outcomes. Let us note down now which are the favorable outcomes. 17, 26, 35, 44, 53, 62, 71, 80. In this case, we have 8 possible outcomes and hence the probability is equal to 8 by 25. By this, we have completed the questions up to question number 5. Thank you, children. Have a nice day.